Hey everyone, I know we're still stuck at home with coronavirus, so I wanted to keep going with this video series. I hope everyone's doing okay and not getting too stir crazy. I'm getting a little stir crazy and I have the goats to keep me busy, so I hope everyone else is doing okay too. So I felt kind of bad about assigning this next sort of section on things like scatterplots because there was a lot of reading in here, and I don't usually give you guys a whole lot that's really reading dependent. So I wanted to take the opportunity to read through it with you guys and do some explanations in a way that hopefully will help this make a little bit more sense. So as we look at, there you are. So scatterplots. So this was the first one where I signed where there was really a lot of reading. So let's talk about this. So here's our introduction. Here's an example. Height and speed in the 800-meter dash. Mr. Watson determined there is a correlation between speed and the height of a student. So let's talk about what correlation means. Correlation means that things seem to trend together. If one goes up, the other one tends to go up. If one goes down, the other one tends to go down. Now, you'll sometimes hear people say that correlation is not causation, and that's true. Sometimes two numbers contract together even if there's nothing that actually connects them. One classic example of this is ice cream sales and drowning deaths. It turns out that both of those go up around the same time in the year, but that's because it's summer and everyone's out eating ice cream and swimming. So they're both more likely to happen in the summer. So they're not, one does not cause the other, they're correlated together. So that's what we mean when we say correlated. They seem to track together. So when he looks at students who run, he gathered these heights and times. So here are the heights and here are the times. Can he support his claim given this data? And this is a really lousy way of displaying it, but that's okay. We're going to sort it out for him anyway. So to prove it, he's going to make a visual display of a data and a correlation between height and time. Scatter plots are great for this because there are a lot of little points that don't necessarily connect. It's not like the height of one person sort of carries over to the height of the next person. So first thing, we're going to make these essentially as an input-output table. In the real world, many things are actually related to each other. The more you smoke, the lower your life expectancy. The more years you spend in college, the greater your income. These things are correlated. In fact, we know that some of these are actually some causation, but for now, correlation. So one tool to show that is a scatter plot. It's a type of graph where corresponding values from a set of data are placed as points on a coordinate plane. A relationship between the points is sometimes shown to be positive, negative, strong, or weak. Sometimes a scatter plot shows no relationship at all. So let's find out what that actually means when we look at this example. So here's an example. A student had a hypothesis for a science project. He believed that the more students studied math, the better their math scores would be. Seems about right. So he took a poll of the number of hours somebody was studying any week and then their percentage grades. Clearly this did not transfer to PDF well. So he took the input data, our independent data, and he put that along, um, on the x-axis. The x-axis is the thing we controlled, and then the y-axis is what happened with it. So he made his scale here from 0 to 7, because the highest value on the x-axis is 6.5, and we can use intervals of 1, which is generally easiest if we can do it. 1s, 5, 10s, those are the numbers people try and use. On the y-axis, since we're 0 to 100, it makes sense to have our scale go from 0 to 100. If we break it up into tens, that seems to give us a pretty useful kind of space to work in. That's sort of a judgment call, and it's okay if you make different decisions. In fact, when we get to misleading data later in the unit, you'll actually see the ways that people can manipulate this to make data look either better or worse. And there's a lot of that going on right now in the news. As you look at some data points, you can make anything look pretty scary if you choose the right scale. All right, so does studying increase your grades? So this is the example where they plotted the number of study hours. So this person studied half an hour a week, and they have a score of about 51. That sort of makes sense. So this is a really useful way because we can actually see this kind of tracks along almost a straight line. So we can actually show that these are a positive relationship. So here's what they have. A positive relationship is as x goes up, y goes up. We have a positive slope. Remember, if we think about reading from left to right, a positive slope is the one where you have to put effort in. You're going to put in some effort and go up the hill. Some points may not follow an exact pattern, but we're looking at an overall trend. For example, this one's off the line. That's okay. We might consider this an outlier. It's not so far off that I'd be worried about it. A negative relationship shows this. As x increases, y decreases. And this one, the slope is not quite as steep, that's fine, but the tendency is still there. And in fact, we'll talk about the strength of the correlation later. Sometimes there's no relationship. You see something, oh no, I thought they had an example of that. Sometimes they're just all over the place and you look at it and it looks like chaos. Don't worry about those. That's just a situation where you didn't find any correlation that time. So then you're going to use the scatter plot to draw a trend line and estimate unknown outputs and given inputs. We're going to make a trend line or a best fit line. So there's a lot of mathematical ways of doing these, and if you take a statistics course, especially if you get into one in college, you're really going to get one that's really exact, and there's in fact an exact way to do it with really complex formulas, and I will tell you that nobody does them by hand. Not even in college, not even once. You do them maybe once by hand with a really tiny example, and you never do them by hand again. You put them into a computer. So I'm not going to make you guys do those because I don't actually think that's a useful thing for you to learn for now. Here's one I might say, this one looks like no relationship. Okay. So what are we going to do? Well, we're going to do a graph and we're going to draw the best line that you can. Now, if you have a graphing calculator, they can actually find this. They actually will call it sometimes a trend line on a graphing calculator. But since we don't have those, especially right now, you're going to make a best fit. Now, if you can figure out the formula for the line, woohoo! All right, so let's go back to the original example. But if you are not ready to figure out the formula for the line because we haven't covered that, don't worry. I was planning this unit for later, but this one was actually easier for you guys to take home with you than the sort of lines unit. Okay, so real life example completed. Height and speed. Does having longer legs, being a taller person, make it easier to run the 800 millimeter? So we've determined that there is a correlation, and here's what he did. Now he put in a scatter plot. He put the data into a table so we can see it very clearly. And this is actually something you'll never stop doing in statistics, data in here. And now, here we go. Whoops. This is not the easiest. You guys are going to love this. All right, let's look at the scatter plot. Does it look like it's accurate? As somebody gets taller, do they go faster? Well, their time does seem to go down, which is kind of what we would have expected, right? The shorter person has a harder time because their legs are just a little bit shorter. All right, so here's our vocabulary review. A scatter plot is a graph where corresponding values are placed on the coordinate plane and the relationship between the values can be determined. What is that in English? Well, it's basically saying it's a graph where we have input and output shown on one table. We graph the input this way and the output that way. And because we do that, we can actually see the relationship between all of the values pretty quickly. The input is the X value. It's the independent. It's the thing we're controlling for. It's the thing we're looking at. It's our hypothesis. The output is, did we get it right or not? Positive correlation is when we have something go up, left to right. Negative is down, left to right. And sometimes a negative correlation is okay. We're not saying negative is bad here, just to be really clear. And no correlation is where things are all over the place. So I want you guys to look at these. I just realized that these are very, very jumbled, so there's nothing you're going to be able to do with that. So do your best to answer what questions you can here. I will send out something to clarify because I did not catch that somehow this PDF, which was intended as a PDF, looks kind of funny. So I hope things are going well. If you do have any questions or need any help with anything, call me at 427-4716. Miss you guys. Bye. Okay, so I'm also going to have a link in the description of this video to the original chapter, and I will send out the new questions. So if you were looking at this and you can't figure out what those points are, that's because they jumbled up in the PDF and I didn't catch it. Sorry, guys. So I will make sure that there's a link to the original in the description of this video, and I will send out a replacement. Thanks, guys.